Thanks very much, Nick. And yeah, thank you for having me there remotely. And yeah, even though it's in rather sad circumstances. So um, I'm not Joyce, and she would have given you, of course, a very different perspective as a climate researcher from Kenya, but also a long-term negotiator for Kenya in the UN negotiations. So that perspective I cannot give. Instead, I will give a perspective from very much the world weather attribution and some of the work that we have done, particularly this year on extreme heat, to show just how strong our scientific understanding is in what causes the impacts or the extreme heat we are seeing and how that affects people today. So this is a snapshot of the attribution studies that my team, that includes Joyce and Emmanuel, um, and also Nick, very often have done over the last 2 years. Just to give you sort of an idea of extreme events that are happening. Of course, these are just the ones that we have studied, and all the pink dots are the ones where we have a very clear connection to human-induced climate change, and where climate change made the event more intense and more likely. And many of these are extreme heat events. And extreme heat waves are happening all over the world. And I'll just very briefly say how we do these studies in a conceptual way, and then talk about who they affect. So one of the studies we did this year was on extreme heat in Europe. Europe had a very warm summer, and you can on the map you can just see the anomalies of the European summer temperatures compared to the 1990 to 2010 average, and you can see that especially in the western and southern parts of Europe, it was extremely warm, and only the countries on the Baltic, Lithuania, Estonia, had a relatively cool summer. And so the first thing we do in an attribution study is to figure out how do we actually characterize this event. And you could do this for if you're interested in just the European summer. You could say, okay, we just look at 3-month average temperatures. But in most cases, especially if you're interested in how heat affects people, it's on shorter time scales and the very high temperatures that are really what causes the most effects on people. And so what we did in this study was that we looked at individual cities across Europe and at individual also at the whole summer, but also at individual heat waves. And so, for example, one of the studies was that we looked at individual heat waves across 12 major cities in Europe, including London. And one of the things, and there was an extreme heat wave at the end of June, at the beginning of July. And so we looked at the 5 hottest days at the end of June and found out that these days were over 33 degrees in maximum temperatures. And that's what we then used, what you can see here in the schematic on the right-hand side, as our event definition. And we found that in the world we live in today, that's actually not a very extreme event, but it's happening relatively frequently and is expected every 5 to 10 years. And we know that because the next step after we have characterized the event, we compare observations and statistical modeling of possible summer temperatures in London at the end of June in the world we live in today, so in the 2025 climate. And that gives you this red distribution curve that you can see on the right-hand side with our observed event. And then the actual attribution step is to then figure out, okay, how would possible June temperatures in London look like in a world that was 1.3 degrees cooler, so in a world without human-induced climate change. And because we know very well how many greenhouse gases have been put into the atmosphere, we can remove these from climate models, atmospheres, but also we can use statistical modeling based on observations and assuming the observations have happened in a 1.3 degree cooler world. And then you also get another distribution, and that you can see here in this slide as the blue distribution. And then you can see that actually, without human-induced climate change, this you would never get the kind of temperatures that we have observed this year in London, but the curve looks very, very similar for many different parts in Europe. But of course, there might have been a heat wave. And so this is what you can see with this small dashed line in the blue curve, that the same kind of heat wave that we have observed that is now about, a bit over 33 degrees is in a world without climate change almost 4 degrees cooler. And so we can say that because of climate change, this heat wave was 4 degrees hotter. And this is how we do these attribution studies. And the science is extremely clear for heat waves around the world. So this is for one data set, and then we would do the same thing, not just in observations, as you see there in blue, but we would also do the same study in many different climate models. And what you can see here in red, with the black bars giving the best estimate, that what in observations is about a 4-degree increase in climate models is only just 2 degrees, which also shows us that actually in Europe, as in many parts of the world, the climate models don't do a very good job in reproducing the warming that we see. So most of our studies are actually conservative in that sense. But when we combine all these different methods and models, we can say that because of climate change, this heat wave was at least 2 degrees hotter than it would have been without climate change. But the question now is, and here you have some results of this for different cities. So, for example, in London, it's about a 1 in 6 year event in the world we live in today. The heat in Milan is, when you look at the return period, is a very common event now, expected almost every other year. And you can see on the right-hand side how much hotter these heat waves that we observed were because of climate change. And only in Lisbon, where we have less warming because it's so close to the Atlantic, we see very strong increase in intensity due to climate change. But still 2 to 4 degrees, if you compare that to daily weather, might not sound very much. And so to figure out what does that actually mean, we need to go a bit deeper into the impacts. And we have done that this year together with colleagues from the Institute of Tropical Medicine and Hygiene, and combined these changes in intensity of heat waves due to climate change with the effect of extreme heat on mortality. And what you can see here on the left-hand side is, sorry, you can't because my cat jumps on the keyboard. What you can see here on the left-hand side is a map with over 800 cities in Europe, and that shows you the temperature from which onwards heat becomes, or the risk of mortality increases with heat. And you can see on the right-hand side the temperature percentile, so how hot compared to the average temperatures you experience, heat becomes dangerous. And you can see that it's the relative risk of mortality is pretty close to zero when we sort of have relatively warm but not hot temperatures, but it increases very, very steeply towards the end of the curve. And so as soon as we get higher temperatures than this percentile, the mortality risk, and particularly for people that are vulnerable and elderly, have pre-existing health conditions, heat can become very dangerous. And combining this knowledge of how these curves look, and they look very different in different cities, with the attribution that we've done, we can then see how the mortality is different in the world we live in today with climate change. So, for example, when you look at the second plot here, which is Barcelona, you have in the purple, you have the temperatures that would have been observed if it wasn't for climate change related to the number of heat deaths. And you can see that even at the hottest part of the heat wave, maybe 20 people would have lost their life. But when you see the same in the orange, which is the actual observed temperatures that are now about 3 degrees warmer because of climate change, you can see that this, at the hottest part of the heat wave, that this figure has almost tripled. And so about 60 people will have lost their lives. And you can see how this differs in different cities. In Lisbon, for example, because it was such an unusual event, it would actually have been also very unusual and deadly without climate change. But the opposite is true for Madrid, where without climate change, what you see on the purple curve, the minimum mortality would actually not have been crossed and almost nobody would have lost their lives. And so we can do this for every city where we have these kind of information and data. And this is just a summary figure of the study, which basically shows that 2/3 of the people who have lost their lives in this heat at the sort of 10 days at the end of June would still be alive if it wasn't for climate change. So this is a really stark translation of what a 2 to 4 degree hotter heat wave actually means. Because it means that many, many people that have died this summer would still be alive without climate change. But of course, human life is not the only thing that is an important impact of extreme heat and extreme events. And I don't want to go into this study, but I just want to flag it to you because I think it's a very, very important study. It's called 1,000 Ways to Experience Loss and Damage, and it just looks at different extreme events and asks people, indigenous and non-indigenous, what they have lost, what has been damaged, and what is at risk, and how they value that. And you can see that human life, of course, is really important, but also other things that we often that we don't have no idea how to measure in many cases, like culture and traditional heritage play a very important role. But of course, second to that is physical health. So it's not just mortality, it's also morbidity, and then mental health and emotional well-being. So two things that have already been talked about. So, and that's much harder to measure that in numbers, but if we have the numbers for the mortality, we can imagine just how much bigger they would be for morbidity. But of course, these numbers, we have them for Europe, and we can do these studies very easily in Europe. In many other parts of the world, it's much harder to do these studies. But of course, that doesn't mean that heat waves don't happen or that they don't have any impacts. And one of the studies on extreme heat we did this year within South Sudan, where we particularly looked at the impacts of this heat on women and girls. And what you can see here in these cartoons is really just the physical attribution study of the hazard. So we found actually a very similar result, that the heat today is about 4 degrees hotter than it would have been without climate change in South Sudan. And when you look at the very busy figure with the dots here, you can see just how much of a change that also means in the likelihood of extreme events like this one occurring. So today, this is a very common event, expected to occur about once in every other year. But without climate change, it would have been exceedingly rare. And in this study, we looked at how it affects particularly women and girls who are, if they have employment, almost all of them are employed in the informal sector, are therefore much more exposed to heat, don't have any any health insurance, don't have any working condition insurance, and so it just a very, very different picture to that we see in Europe. Another really important impact is the impact on education because it was too hot to go to school. The school buildings which had metal roofs were so hot that it was dangerous to be in there, and children actually collapsed, which was how we even knew that this heat wave happened. And that means that schools were closed for a long time, which has particularly negative impacts for girls because that often means that they then get more work at home, and families rely more on them, and many of them will never go back to school, which has obviously terrible consequences for the rest of their lives. So this is the science. We know very well the impact of climate change. We can calculate that. We can calculate and translate that, what that means for mortality. And even when we don't have data, we can qualitatively look at many of the pathways, how extreme heat affects people. So what can we do as a community to do something about this? So the first thing is to actually record heat waves. So what you can see here on the left-hand side is a map from the global disaster database, EMDAT, which is the most complete database you have on extreme events and resulting disasters. And when you look at particularly Africa, but also many parts of Asia, you see here in gray all the countries where no heat wave has ever been recorded. And when you look on the right-hand side, which shows you a distribution of globally available weather stations that have strong trends, the ones in red have strong trends in observed temperatures and therefore have many heat waves. And you can see that there's a big discrepancy. So even though there are many gaps in the database of observed temperatures, we have a lot of data, for example, for Western Africa, but no heat waves are recorded in the database. So that is sort of the first step, is to record heat waves, to make people aware that they exist, to find out ways of how we can characterize heat waves in countries that have traditionally not recorded them, so that we know what is actually happening. And then the next step is to understand the pathways of how extreme heat impacts people. And one, of course, is the direct impact from heat, health to health and physical and mental well-being. But of course, there's then many other ways with people in informal settlements. It means, of course, the physical impacts, but also access to water becomes a huge problem. Transport systems are affected, which means also access to water, but also access to medical care becomes much more difficult. And so there are all these sort of second and third layers of impacts of how heat affects health and who is particularly affected. There are the people we traditionally think of as vulnerable, the elderly or people with underlying health conditions, but of course also people working outdoors, but also people that are not necessarily traditionally thought of as vulnerable. And that's also really important, because otherwise these people we will not think about them when thinking about adaptation planning. And that is something that also Emmanuel mentioned it earlier, that a lot of parts of the world now do realize how dangerous heat is and have something that's called a heat action plan, so that you have not only record heat waves and give early warning, but you also have a plan of what to do, how to make sure that the vulnerable in your community are aware, have cool rooms to go to, have water to drink. And here on the right-hand side are some examples. So some, like the one in Pakistan, have this on a national level, but the one from Truro in India, this is much more local, and the same is true for the one from Australia and Tasmania. But when you look at the map on the left-hand side, you can see there are now many parts in the world that do have heat action plans, but there are also many, many parts of the world that don't have them yet. And that is one really important step towards protecting lives. And the last, and of course, probably most difficult, is to overcome some of the global barriers. Um, One of them is funding. So, Running on Empty is the title of the adaptation gap report of this year. And what you can see there on the left-hand side is funding for mitigation. And the teeny tiny blue bar in the middle is the funding for adaptation. And that, of course, is a big problem because you need at least to pay the salaries of people who can implement adaptation plans. And then I've already mentioned that we don't know in many parts even how to measure heat waves, or they are not measures. And that, of course, has also a big impact on global climate diplomacy, that we don't have measurable goals or quantitative goals that allow progress to be tracked. And while, of course, there are a lot of things that are important that you can't quantify, you need a way to be able to have clear goals and to track progress if they are quantitative or qualitative. And at the moment, we don't have that for adaptation and definitely not for loss and damage where heat and health really falls into. So a lot to do, and I'm sorry I can't be there and exchange some ideas of how we can do that. But I wish you good luck. Thank you.